Welcome back. This is Module 4, Topic 1, Lesson 3, Toss the Cup. In this lesson, we're going to be determining experimental probability. In this first activity, we're going to be focusing on this first learning goal, which is predicting the experimental probability of a chance event by collecting data in a probability experiment. And our key terms we're going to be learning in this activity as well are theoretical probability, say theoretical probability, and experimental probability. Say experimental probability. All right, let's get to it. This is activity 3.1, determining experimental probability. Let's get started. Two friends are designing a game called Toss the Cup. The game is played between two players. To play the game, a paper or plastic cup is needed. To start the game, the paper cup is tossed in the air. If the cup lands on its bottom, player 1 wins a point. If a cup lands on its top, player 2 wins a point. And if the cup lands on its side, neither player receives a point. Now, I wish I had a real cup to give to you and give it to you through the screen. However, I can't do that. So I went ahead and did the experiment for you, which I will let you see in a few moments. But let's discuss and answer some of these questions first. So, number one, it says predict the probability for each position in which the cup can land. Well, looking at the positions, we've got the top, the bottom, and the side. We can kind of predict what it might be. What do you think? Now, it's really hard to predict which exactly it's going to land on, but using our knowledge of basic probability, of simple probability, we can guess, make an educated guess. And also, too, when I taught this last year, my students guessed this, but they said probably there's a 1 out of 3 chance that it'll land on each side because there are 3 sides and they all have an equally likely chance. But if you don't agree, we can talk about that in a few. And also, you will see in the experiment what actually happens. All right, number 2, it says list the sample space for the game. So the sample space, remember, has brackets like this, and the sample space is just the outcomes. So what are the outcomes of this experiment? And if you want to write them before I do, then be my guest. So the first one is it could land on its bottom, it could land on its side, or it could land on the top. And there's our sample space. Question number 3. It says, can you use the sample space to determine the probability that the cup lands on its top, bottom, or side? Explain why or why not. Now, this is where I want you to take a moment to discuss. And then question number 4, it says, do you think all outcomes are equally likely? Explain your reasoning. So we're going to pause here, set a timer for about 1 minute, and I want you to discuss and answer on your own questions 3 and 4. Pause here, 1 minute. Alrighty, now that you've had a minute to discuss, your answers, of course, are all very different, but I'm just going to show you what I've got, and these answers are based off of, like I said, what my students discussed last year. So, for number 3, can the sample space be used to determine the probability? You could have said yes, because they all have an equally likely chance. Sure, there's no wrong answer here for predicting. Or you could have said no, because no one knows what will actually happen because of gravity, weight, how it's flipped, or who flips it. And there, of course, are other factors that you may have written down on your paper. Number 4, do you think all outcomes are equally likely? You could have said yes, and don't forget to explain. And you could have said no and explained your reasoning. And it could have been based off of your answer number 3. So now let's move forward and actually toss this cup. So, number 5, it says play the game 25 times with a partner. Decide who will be player one, who will be player two. Now, like I said, I wish I had a cup to give you through the screen. However, I don't. This is digital, so we got to make it work. All right. Part A says record your results in the table using tally marks to total up the scores, and then we're going to summarize our results. So I'm going to cut here, somewhere in here, and you're going to see not the full 2 minutes of me flipping this cup, but you're going to see the last 45 seconds of me flipping the cup and recording my results. And then we're going to come back to this table and talk about it. Alrighty, we've completed the experiment, and I know that you weren't given enough time to, or weren't given time to record your results in tally marks and total it up. So go ahead and copy that down, the results of our experiment. And also at the same time, go ahead and answer B and summarize your results. So record the data and answer B, summarize the results. Take about 1 minute max. 1 minute. Pause here. Alrighty, of course, we probably all have, or not probably, we definitely do have different summaries of our results. I hope you discuss them with the neighbor, but I'm just going to share with what I have. So I put the cup landed on its side the most of the time, and sometimes on its top, but never on its bottom. So this game would be unfair, of course, to player one. All right, let's move forward because here is some key learning for this activity here today, really for this lesson. So we've got some vocabulary. It says the theoretical probability. Don't forget to highlight, underline, circle it, whatever you need to do to highlight this vocabulary word. The theoretical probability of an event is the ratio of the number of desired outcomes to the total number of possible outcomes. So, theoretical probability is what we did in the last two lessons, determining what should happen, right? This is the kind of probability you've been working with in the previous lessons. Oh, I guess I could have kept reading. Anyways, an experimental probability is the ratio of the number of times an event occurs to the total number of trials performed. So in short, I'm going to make a note off to the side that you can also take. So theoretical is, take a second to copy if you need to. Off to the side, I simply put theoretical is what should happen, and experimental is what actually happens. And here is the formula for that. The number of times the event occurs, how many times it actually occurs, over the total number of trials performed. So now we're going to write the experimental probability of the activity that we just did with the cup tossing activity. So using my data, number 6 says, what is the experimental probability of the cup landing on its bottom, on its top, or on its side? I'm going to do one just to show you what it would look like or what it should look like when you complete this. And then you're going to answer the rest of these questions on your own. So the probability of it landing on its bottom, well, looking at our table, we could clearly see that it landed on its bottom 0 times out of how many total trials? 25. So there's my experimental probability for the cup landing on its bottom. Then you're going to answer B and C on your own. Number 7 says, do you think this is a fair game to play? Why or why not? You're answering that. And then number 8 says, is it possible to determine the exact probability of a cup landing on its top, bottom, or side? And you're going to explain why or why not. All right, set a timer for about 2 minutes max, and go ahead and answer 6 through 8. Pause here. Alrighty, let's compare answers. For 6, we should all have the same answers. The probability of it landing on its top is 8 out of 25, and the probability of it landing on its side is 17 out of 25. Now, for 7 and 8, we all should have different answers. You should have already shared your answer with a neighbor, but I'm going to go ahead and share what I simply put as a general answer. So, is this a fair game? No, this is not a fair game because the cup has a greater chance of landing on its side than the top or the bottom. And number 8, is it possible to determine the exact probability of the cup landing on its top, bottom, or side? No, it's all up left to chance. So the answer is no. I hope you have answers similar to mine. And this activity, well, that concludes this activity on experimental probability. I will see you in the next video.